Hello, welcome back to Religion and Science after our extended spring break. We'll first do a little bit of redux, or going back to some stuff we talked about earlier in some way or other. First of all, this one is the age of the universe, a little bit more on that, and evidence for the ancient nature of our universe. This and a little bit more on evolution, which will be the next mini lecture, could be helpful on answering the last question on the final exam, which is posted now on Canvas. So, the age of the universe. What evidence do we have that the universe is about 13.8 billion years old? And you do have on Module 1 for this new online format, this brave new world, notes on the age of the universe. Well, one point is that uranium, the elements uranium and thorium, are produced in supernovae, which go back to 6.8 billion years ago, plus or minus 2.2 billion years. So that's about 9 billion years that we know the supernova themselves are that old. What about fusion in the sun? And that involves 4 hydrogen atoms becoming helium. And that goes back 5 billion years ago. Some more stellar or star kind of information, evidence for the ancient nature of the universe are globular star clusters. Their varying brightness, their different colors show us that they go back to 11.5 billion years ago. What about white dwarfs, which are another kind of star that's reached the end of its period? Their brightness and color shows them going back to 9.3 billion years ago. There's the recalibration involving what's called the Hubble constant, something important in physics and astronomy, and, which we've already mentioned a time or two, is the cosmic background radiation that goes back to 13.8 billion years, plus or minus 200 million years, as far as a margin of error. We've also mentioned that the formation of heavier elements involved all these different cycles, these recycling of stars coming into existence, being birthed, that is, then living out their lives, shining, and then finally losing all their energy, losing all their hydrogen, and becoming helium and other harder, heavier elements as later generations of stars happened. What about on Earth? The ancientness of the Earth, which is 4.5 billion years ago. Well, there's sedimentation and layering of the rocks and other layers of the Earth. There's the fossil record. There's, of course, radioactive dating. There's the shifting of continents. And there's genetic evidence of living creatures that go back a very, very long time. So, that's a little bit about all the different ways that we know scientifically we're certain. It's not just a theory in the sense of it's a hypothesis that waits to be proven. No, the ancient nature of the Earth has been proven scientifically redundantly in many, many different ways. And that's typically the way it is when we talk about basic features, including the basic chronology, the basic timeline of the universe, our solar system. our Earth. It's just a whole bunch of intersecting evidence, cumulative evidence, that cannot be debunked by picky little arguments that supposedly try to pick apart particular aspects of it, which are these arguments by young Earth creationists, for example, are totally demolished. They're able to be individually discredited by scientists, but the larger point is that there's this whole accumulation of evidence that our universe is extremely old, extremely ancient.